Good evening, all. Am I audible?
Yes, ma'am.
All right.
Yes, ma'am.
Yeah, thank you for your response, people. People, I have shared my screen. Kindly acknowledge if my screen is visible.
No, ma'am.
No, ma'am.
No, ma'am.
Now visible, ma'am.
Ah, okay.
Now visible.
All right, great. Okay. All right, people. So, so first topic is of number representation. So, do you all know how to represent what is decimal, what is octal, what is binary, and all?
Yes, ma'am.
Okay, what is decimal?
Yes, ma'am.
What is decimal number?
Decimal number system have base 10, 10 to the power 0, 1, and so on.
Okay, right. It's like a base 10,
And background noise is coming.
not from
Sometimes.
my end. All right. So let's say if I'm taking a number, let's say it's 10. So here I'm just writing as 10 to the base of 10, which means it is considered as a decimal value. Okay. Similarly, what is a binary?
Zeros and
Numbers
ones.
have base 2.
Which one is computer
Ah,
understand?
yes. It's a base 2. So the thing is, if the value is binary in the sense of it can have the values of 0 and 1. Decimal in the sense of 10, which means it can have the values from 0 to 9. Okay. What is octal then?
Base 8.
Yes, to the base of
0 to 7.
exactly. It will have the values from 0 to 7 and the base is 8. Okay. So let's say a number is given as 10. So here we'll give the values. So if it is of binary in the sense of it can have the values as 0 and 1. So 0 to n minus 1. What the base is. If it is of octal value, it can have the numbers from 0 to till 7. So till 7 it can have as a number. So this will say it as the base 8. That is nothing but octal. How about to the base 16?
0 to 9, and after that
Hexadecimal.
A, B, C, D, E, F.
Exactly. 0 to 9. After that, A to F. Which means A is considered as 10, B is 11, C is 12, like that. Till 15, it will be considered. So F is considered as 15. Is this clear, people?
Yes, ma'am.
Okay. So now, let's say a decimal value of 26 is given. So how will you convert this decimal to binary? Which means 26 to the base 10 need to be converted to the base 2. How to do that?
We take
By
the
the
highest power,
division method.
which is less than 26.
By?
We take the highest power of 2, which is
By
less
the
than 26.
division method.
Yes, we can do it by using division method. Good. And the other is of
We using a shortcut method also.
yes, 2
Shortcut
to the
method
power
also.
of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, and it goes on. By this way also we can be able to calculate it. So first let me take this L division method. Now the 26 is given. So first we have to divide it by 10. So what is the quotient and what is the remainder?
Quotient is
Remainder
13
is
and
1
remainder is
question, and sorry, remainder is 0.
Yes,
0.
remainder is 0. Then again dividing 30.
quotient is
Question
6 and
remainder is
remainder
1
is
and
1.
question is
Yes. So here we'll get the quotient as 6, remainder is 1. And again dividing 6 by 2.
remainder is 0, question 3.
Okay. Again dividing by 2.
Remainder 1, question 1.
Yes. Quotient is also 1, remainder is also 1. So now we have to write this from lower, like from the quotient to all the reminders. Which means we have to write it as 0, 1, 0, 1, 1. Okay, so this will be the binary representation of the given 26. Now, how to check whether the value I have got is right or wrong?
By
By
place,
putting
2
two
powers.
two's the power and add them.
Exactly. So, what I
In the
can,
place of 1,
yes. So, what I need to do is we can just check it by using the 2 to the basis. So, 2 to the power of 0, 2 to the power of 1. Like this way, we'll keep writing the values. And it goes on. So, this is 2 to the power of 0. What is 2 to the power of 0?
1.
1.
1.
Here we'll get 2 to the power of 1. What is 2 to the power of 1?
2,
Yes.
2.
2 to the power of
2.
2 is?
4,
4.
Yes, it's 4. And what is 2 to the power of 3?
8,
8. And what is 2 to the power of 4?
16,
16.
16.
Exactly, it's 16. So I have to give it as, here 1 is given. So 1 into 16 plus, I have to take the next element here 1. So 1 into 8 plus 0 into
0.
4 plus 2 into 1 plus
21.
0 into 1. So what is the value we'll get?
26.
16 plus 8
26.
plus 0 plus 2 plus 0. Right? Which is nothing but 26. Isn't it?
26.
Yeah. Which means whatever we have did in the conversion is right. So here we can write it as 11010. So this is the binary representation of the given decimal number. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay, can I give you one more number? Can you all tell me what the binary representation for that decimal value?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, I'll drop it in the chat box now. Yes, my screen is visible. What happened? For others, it's visible, right?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, I have given some values in the chat box, people. You can just convert those numbers into a binary representation. "56 to the base 10, which has to be converted to base 2.
Ma'am,
Huh?
ma'am, the binary representation.
Binary representation? Yes, what's the question?
Done, ma'am. Done.
Yeah, I could see response of few people in the chat box. Good. Yes, good people. Yes,
Ma'am, I have solved.
good. People, have you all tried?
Yeah, ma'am.
Alright. Can we
Yes, ma'am.
check if the answer is right or wrong? No, for 8,
Yes, ma'am.
wrong, ma. Could you please check? For 8, what you have sent is wrong. Anjali, please check. Okay, so first value which I have given is 56. So for 56, how will you convert it, people? As usual, you can just use this L
Can-
division method, or else you can just use this 2 to the power also. Okay. So in this case, let's say I'm using this 2 to the power base values. So 56 is given. So initially I'm taking 2 to the power of 0, 2 to the power of 1, then 2 to the power of 2, then 2 to the power of 3, and then 2 to the power of 4, and then 2 to the power of 5, and it goes on. Okay, so what is 2 to the power of 2? 2 to the power of 0?
1. 2 to the power 0, 1.
1.
Yes. And what is 2 to the power of, it's 1, right? Okay. And what is 2 to the power of 1?
2.
2. 2.
2 to the power of 2 is 4.
2,
This is 8.
4,
And this
4.
is 16.
8,
And this is of,
16, and
And
32.
32.
and 2 to the power of 6 value is 60.
64.
64.
Okay. So the first value which I have got is 56. So here, even this 5-bit representation is enough, right? So 32 is filled. So what is the next value to be filled?
16.
16 plus 8.
16.
Okay, so first value was 56, out of which I have filled 32. The remaining is 24. Of course, I can fill 16. So
And
now
8 also.
I can fill
8.
8. So after adding all these things, I'll get the value as 56. The remaining all filled with zeros. And what is the next value I have given here?
12.
12.
Yeah, 12. And then the next value is 9.
And 8.
Next is 8, right? Okay. So let's say if I have to represent 12, then of course 12 is lesser than all these values. Then 8 is comparing to 8, 12 is greater. So fill here. Remaining is 4, 1, 0, and 0. Okay, and next is of 8. So for 8, all the values are 0 except this one. Okay, and if it is of 9, it's like 8 plus 1. Remaining are all filled with zeros. Have you all got an idea now, people?
Yes, ma'am.
Yes, everyone?
Yes, ma'am.
Great. So this is
Yes, ma'am.
how
Yes,
we'll
ma'am.
try to convert to the base 10 value. That is nothing but decimal value to a binary value. Next is of octal. So let's say the octal number is, let's say the given decimal is 15. So if it is a 15, how will you convert it to a 15 to the base 10? How to convert it to base 8? Any idea?
And now we will divide it by 8.
Exactly. We
8.
have to do it by
Instead,
dividing by 8. So what
instead
is
of
15 divided by 8? What is the quotient and what is the remainder?
Quotient is 1
reminder
and
is
remainder is
7 and the
7.
question is
Quotient
1.
will
Remainder is 7,
remainder will
quotient
7.
is 1. So I have to write this as 17. So here it is of 17 to the base of 8. So if it is of vice versa, octal to decimal, then
Ma'am,
yes.
multiplying 8 का powers
Then, then
like
ma'am,
value
we will expand it in the terms of like 8 into something like in the decimal number system, we will use 10 raised to power into something plus plus. Instead, in the octal number system, we will use 8 instead of 10.
Exactly, like same similar to binary. Binary, what we did, we have raised everything to the power of, to the base of 2 to the power. Here we
Yes,
have to take the base as 8.
yes, ma'am.
Okay, 8 to the power of 0, 8 to the power of 1, 8 to the power of 2, like this it keeps going. And then 8 to the power of 3, 8 to the power of 4, like this. and it keeps going. So what I need to do, let's say it is 17. So it is like what is 8 to
8
the
to the
power of
power
0?
2
So anything power 0 was considered as 1.
1.
So 1 into 7 plus 1 into 8, which is nothing but 15. Is this
15.
clear?
Yes,
Yes, ma'am.
ma'am.
Okay.
Yes, ma'am.
Let's say I'm taking the number as 12. Or let me take some value as 36. Okay. How will you represent this 36 to the base of 8?
So basically, ma'am, we will use division method and
Yes,
calculate
8.
it.
Okay. What is the What is the quotient and what is the remainder?
4 is the question, ma'am.
Hmm.
Remainder will be 4 and the
Okay.
quotient
Remainder
will
is
also
4,
4.
right?
And quotient
Quotient
will also
Quotient
4.
is also 4.
Quotient is also 4. So we represent as 44
Base 4.
to the base of 8.
8.
Okay. So if you want to check also, you can check as 4 into 8 to the power of 1 plus 4 into 8 to the power of 0.
0.
Which means which is nothing but 4 into 1 plus 32 plus 4 will get it as 36. Is this clear, people?
Yes, ma'am.
Yes, ma'am.
Have you
Yes,
all got
ma'am.
an idea like how to convert this?
Yes, ma'am.
Yes, Syed. What's
Yes,
your
ma'am.
doubt?
All clear.
Ma'am, can you explain it once again?
Yeah, sure. Let's take the value as 52. So this is of base 10. I have to convert it to the base 8. So how to convert this? That's the question, right? So what I need to do is we have to keep dividing by 8. So 52 divided by 8. What is the quotient?
6, ma'am.
Yes, 6 is the quotient. What is the remainder?
I'm 4.
Exactly. The remainder is 4. So I have to write it as 64 to the base of 8. If you want to check it, how we checked in binary, the same way. So first is 8 to the power of 0, then next is 8 to the power of 1, next is 8 to the power of 2, 8 to the power of 3, 8 to the power of 4, and it goes on. Here, all the values are 0 initially. Here it is 6 and here it is 4. Okay, so how to check this? It's like 6 into 8 to the power of 1 plus 4 into 8 to the power of 0. So what is 8 to the power of 0?
1.
1.
Yeah, which means 4 into 1 plus what is 6? 8 to the power of 1?
8. 8.
Yes, which means here I'll get it as 6 into 8. What is 6 into 8 plus 4?
48. 48 plus
48
52,
plus
ma'am.
4 is 52. So I'll get it as 52, which is to the base of 10. So whatever I have tried finding, whatever I have converted to octal is right. This is how we have to convert from binary to, decimal to octal and octal to decimal also. If the number is less than 7, of course that will be the remainder. Only that is represented. If it is of 7, what is its remainder? Its remainder is also 7, right? So the 7 is the octal representation also. Can you see here? Here I have got 4. 4 is nothing but the lesser than 8. That's why I have taken that as the stop point. Let's say if I'm taking the number as 122. Now, if I divide by 8, what I'll try to do? So this 122 divided by 8. What is the quotient first?
15, ma'am.
It's 15, right? 15 into 2, 8, I'll get it as 120. And the remainder is 2. Now again I'll divide by 8 because 15 is greater than 8. So again, 15 divided by 8. What is the quotient?
Quotient is 1 and
1.
remainder is 7.
Remainder is?
Yes.
7.
7.
Exactly. So if the value is lesser, then we will stop that. I mean, we are taking that as a stop point. If it is not lesser, we'll keep dividing, right?
Yes, ma'am.
Yes.
Yeah,
Yes,
that's
ma'am.
how we'll do here as well. Is that clear, people?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Adanand?
Yes, ma'am.
All right. So can I give the numbers for you to try converting from decimal to an octal now?
Yeah, sure, ma'am.
Yes, ma'am.
Okay, good.
Yes, ma'am.
So the values are yes, I have given in the chat box now. The number to be converted are 156, 5, 9, and then 39. So try the answer for this and send it in chat box. Yes, I could see people are sending answers. Good people. It's 47. Okay. Okay. Have you all completed more or you want some more time? Yes, what's your doubt? Done. Okay. Done. Yes, good people. Okay. So the numbers which I have given first is of 156. So first let me write this one. First we have to write 8 to the basis, right? So 8 to the power of 0. Then the next is of 8 to the 8 to the power of 1. Then yeah, so the next is of 8 to the power of 2. Then next is 8 to the power of 3. And then 8 to the power of 4, 8 to the power of 5, and it goes on. Okay. So what I need to do first, what is 8 to the power of 1, 0?
1.
A to the power of 1 is?
8.
A to the power of 2 is?
64.
60. And what is A to the power of 3? Sorry, yeah.
216.
Okay, 8 to the 8 into 8 into 8, right? 64 into 8.
4096.
It's 512. Okay. All right. So now, what are the numbers given here? The first is 156. So how to represent 156?
234, ma'am.
Okay. So let's check as well. So 156 divided by 8. So what is the quotient?
4.
19.
19.
Yes. So 19 into 8, I'll get it as 152. And what is the remainder? It's 4.
4.
Okay. And then again, I have to divide the 19 by 8. So what is 19 by 8?
Quotient is 2 and remainder is 3.
Yes. Quotient is 2 and the remainder is 3. So I have to represent as 2, 3, 4. Okay. And the next number given is 5. Which means we can take the same number itself, which is the same octal also. Okay. And next is 9. 9 in the sense? What is its quotient?
Quotient is 1 and remainder
Quotient is
is
also 1. Yes.
1.
I can represent like this. Sorry. If it is a 5, it's only 0, 1 only. And for 9, I'll get it as 1 and 1. And the next number is 39. How about 39?
quotient is 4 and remainder is 7.
Quotient is 4 and the remainder is 7. Is these things clear, people?
Yes, ma'am.
All right. So next is of
Yes, ma'am.
hexadecimal. So as I mentioned, you can see here, the numbers will be from 0 to 9 and then A to F. Okay, A in the sense of 10 and B is 11 and it keeps going till 50. Okay, so here a decimal number is given. Let's say the number is 419. So what is hexadecimal?
Base to the power 16.
It's base 16. It's not power 16, to the base 16.
Base
So
16.
first we have to divide 419 divided by 16. What is the quotient? Uh, 26, right? Yes. 26 into 16, I'll get it as 416. What is the remainder?
Maybe
3.
3.
3.
Okay, again 26 divided by 16.
1. Quotient is 1 and
Quotient
remainder is
1,
3.
remainder will be 10.
Remainder is
10.
10. So in case of hexadecimal, how will we represent 10?
A.
A.
Exactly.
Capital.
You can just check here also, people. If it is of A, we have to represent. If it is 10, we have to represent as. So what is the value here? We have got 1A and 1A3 to the base of.
Yes.
So this is the decimal equivalent of, for 419 decimal, the value to the base of 16 is 1A3. Okay. Similarly, let's say the given value is 562. So what we need to do? This 562 has to be divided by 16. So we'll get it as 35 as the quotient. And the remainder is 2. Okay. Again, 36 divided by 16.
2 as a quotient and
Okay.
3 as a remainder.
3 is remainder.
Yes. So I have to represent as 232. If the value is 0 to 9, you can just use the same value. If the value is like 10, 11 or something, we have to use the letters like A to F. Okay. Is this conversion is clear to you all?
Ma'am, can you repeat it again?
Yeah, sure. I'll take some other value here as a lesser value is 250. So I have to divide it by 16. So now tell me what is the quotient? Or let's take some more lesser value also. 37. So first I have to divide it by 16. What is the quotient now?
2,
Yes, 2. What is the remainder?
5.
Yes. So I have to write it as 25 to the base of 16. Okay. Let's say if the value was 26. How will you convert it to the base 16? What is the quotient?
Quotient is 1, remainder is 10, and we'll write as A.
Yes. So I have to write it as 1a to the base of 16. Is it clear?
Yes, ma'am.
To everyone?
Ma'am, actually, I have a problem to convert into A. Can you explain these? How could we convert into A?
Okay. Let's say if I'm getting the remainder as 10, you can just keep these things in mind. Ma. If the remainder is 10, you have to write it as A. Instead of 10, we are writing as A. Instead of 11, we have to write it as B. That's it. If it is of 0 to 9, you can just write in the same way. But only if you are getting the remainder as 10, you have to write it as A. If it is of 11, you have to write it as B, like this way. Instead of 10, we are writing A. That's it. No conversion, nothing in that.
Got it, ma'am.
Okay, let's say I'm giving the input as 162. So if I'm dividing by 6,
What if we get 16? Then we have to write G or write 16?
will we get 16?
A
No.
reminder, as a reminder.
Of course, we'll not get the remainder as 16, right? If it is 16,
Oh,
it is
yeah, yeah,
divided.
yeah. Yeah, got it.
Yes, exactly. Remainder will not get it as 16. Generally, the remainder values will occur from 0 to the value minus 1. That's what we'll say it as a remainder. If it is equal, no, like, of course, we can divide it again. Or it will be divisible by the next number, like that. Okay, let's say I'm taking 162 to the base 16. How will you convert? What is the quotient?
Ma'am, repeat.
Quotient is 10, and remainder is
Yes, we have to give it as A. And what is the remainder?
2.
2. I should not give it as 10. I have to give it as A. So here it is A2 to the base of 16. Is this clear, people?
Yes, ma'am.
Yeah, ma'am.
Okay, then can I give some numbers for you to try converting?
Yes, ma'am.
Okay. Sorry. Yes, I have sent it in the chat box now. Try the conversion and send the answers in chat box, people. I'll give you further 1 more minute, people. Try completing it. I want everyone to try. Yes, people. Have you all completed?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So what is this 169? How to convert it, people?
Di- Firstly divide by 16,
Yes.
and I got 36 as a quotient and 13 as a remainder.
Okay, 169 divided by 16, you got?
No, 169 divided by 16 will get
Quotient is A and
quotient
remainder
is
is 9.
9. Yes,
Yes, so we have to represent this
A9.
A9 to the base of 16. 16. Okay. And the next value which I have given is 580. 589. Can someone else tell me how to convert this?
Yes, ma'am. 16 divide this, and the quotient will 36 and the remainder will 13.
So we'll write 13 as D. Quotient is 36 and remainder is D. Okay. Then further dividing 36.
Quotient will 2 and
Quotient is
remainder
2
will
and
4.
remainder is 4. Okay, so we have to write it as
240 or 240.
24D to the base of 16. Is that clear? And how about 12?
12 is simply C.
Let's see.
Yes, 12 is the same to the base of 16 also. And how about 98 people? Can someone else tell? For people who have previously answered, you can just wait or let others answer.
2, ma'am, to the base.
Quotient equals to 6 and remainder will be
2.
2. Then it will be
2.
62.
Okay, so here I'll represent as 62 to the base of 60. Okay, so you can cross verify your answers as well, people. Have you all understood so far? Any doubts in converting all these things?
It's clear, ma'am.
Great.
No, ma'am.
The next,
But, ma'am, one more doubt.
yes, please.
But we can also convert this one to another form with the help of binary system.
Yes. Wait, I'm just going to proceed with that next. So far, we have just used decimal to other. That is decimal to octal, binary, and all. So now octal to binary, that vice versa is also done. So next is decimal to hexadecimal. Is it possible? That is also we have tried, right?
Yes, ma'am.
Okay. Then octal to binary is not tried yet. How to convert from octal to binary?
Ma'am, simply divide and pair the three.
I'm not getting it.
Ma'am, if the value is octal, then I will convert into a base 10, and after that we will convert into the binary.
So you're saying that converting from octal to decimal, from
Decimal,
decimal to binary.
yeah.
Okay. Any other ways? Or what is your opinion, people?
I'm
We
converting.
can also multiply by uh, 8 to the power 0, 8 to the power 1, and so on. By this process, we can also get the value.
Okay. Others, what is your idea on this? How to convert a octal to a binary?
I'm converting decimal into hexa and writing the remainders as it.
I didn't get you.
I'm converting decimals, converting octal into binary equivalents and writing it as it is.
Okay, how will you convert that binary equivalence?
Sorry, what, ma'am?
I'm asking that how will you convert it to a binary equivalence actually? Exactly 3 binary digits. Okay. Convert into decimal. After that, we convert into a binary. Okay. All right. So I'll tell you people. So if I have to convert from octal to a binary in the sense of, as you mentioned, you can just convert from octal to a decimal, and from there you can convert, or else you can just convert from uh, octal to a hexadecimal, and from that also you can be able to convert it. Okay, so first let me take this octal value as 540, let's say. Let's say it is to the base of 8. So what is the one way we can just write its numbers, which is nothing but what is the value? How will you write the 5 to a binary value?
1 0
1
1 0
0. 1 is the binary representation of
yes
5. How about 4?
1 0 0
Yes, 1 0 0. How about 0?
0 simply
0. Okay. So here, how I have to write in the sense of, first I have to convert all, which I mean like combine all, which means 1 0 1, 1 0 0, and all zeros. So this is how also you can straight away convert it to a binary. So this is one way of converting. Can you all able to understand this?
yes ma'am simple
Okay.
way.
The other way is converting it to a decimal value. So how will you convert 540 into a decimal?
uh,
5
multiply
into 8 to the base of 2 plus
4 into
4 into,
8 to the power 1
yes, 8 to the power of 1 plus
0 into 8 to the power 0
1 minute, 0 into 8 to the power of 0. Which means here I'll get 5 into 5 into 8 into 8 is 64. So 64 into 5, I'll get it as 320, right?
yes ma'am
Yes. Plus I have to take
34
8 into 4, which is nothing but 32.
32
Yeah. And the last value is 0. Which means I have to add 320 plus
352.
32. I'm getting is 352. Okay. Then what? This is to the base of 10. What I need to do then after this? I have to convert
Simply
it to
convert this
Convert
binary
it
value
into
to
binary value, which is nothing but 1, 2, 4, 8, 16, like that way. So here we require till 256, right? So 256 and then 128, then 64, 32, 16, 8, 4, 2, 1. Okay. So first is I'll give it as 1 here. Then if I subtract 352 minus 256, I'll get it as 696. So 96 is less than this 128, so 0. So I can use 64, 1, and then 32, 1, remaining all are zeros. Which is similar to this, right? Here also we have 5 zeros, 2, 1, 0, 1. Is this clear, people?
yes, ma'am.
Yes. So these are the way of converting it, people. Is this clear?
Yes, ma'am.
Great. So this is the way of converting the octal to a binary. Do you want me to give some examples for this or is this fine? Can I give you 2 examples then for conversion purpose?
Yes,
Yes,
ma'am.
ma'am.
Okay. I have given 2 numbers for conversion, people, octal to binary. One is 98 and the other is 692. Number is too large in the sense of? Yes, Rahul. What's your doubt? Based on the number, the binary value will also be the bigger one. Let's say instead of till 1024, it may extend to 2048 also. Or based on that, it will keep increasing. There is no restrictions in that. Okay. The 2 powers will increase. Based on that, you have to represent. Yes, I'll give you further 2 more minutes, people. I want everyone to give it a try. Okay, once it is done, share it in the chat box. I could see very few people have responded to this.
Yes, have you all tried, people?
Yes, ma'am.
All right, great. So shall we check the answers then?
Yes, ma'am.
Okay. So first thing is we have to convert this 98, right? Okay. So first we can just write straight away as 98. Okay. 98 to the base of 10. Sorry. To the base of 8, right? How to write that?
Firstly, we convert 8 into binary, and
Huh.
after that 9 into binary.
Okay. Perfect. So first thing is I'll just take this as 98 to the base of. Is my writing so visible?
Yes, ma'am.
Okay. So, I'm sorry. 98 to the base of 8, which has to be converted. So initially I'm taking 9. How to write the 9?
1001.
1001. How about 8? It's 1,
1000.
0 and 0. Okay. So this will be the binary conversion of this one. Okay. If you have a doubt, you can just try the same as converting it to a decimal, and from decimal also you can try it. Okay. So if I try to convert this to a decimal, then it's like 9 into 8. What is 9 8s are 72 plus 8. I'll get it as 80 as the value, right? So now what I need to do, I have to take 80 divided by 2. So I can straight away write that, right? Because it's like 1, 2, 4, 8, 16, 32, and 64. So I can fill as 64. So if I subtract 64 from that, I'll get the value as 16. So 1. Am I right? Yes, 9 into 8. And then we have to take this 8 value to it. So I'll get it as 80. So here 64 plus 16 is 80. So yes, so this will be the conversion of this one, right? One more thing is here I have given us the octal value. I'm trying to give it as 9, right? So 9 cannot be octal value, isn't it? And 8 also I cannot give it as an octal value. So actually the thing which I have given is wrong. I said, right, like octal in the sense of it should have a reminders from 0 to 7. So I can give it as 62 like this. And also 8-bit representation will not get all these 4 digits. It will get only 3 digits. So if I have to convert it to I have to convert 62 to the base of 8. Actually, whatever the numbers which I have given is not a valid one. This 98 and 692. Instead of 9, I should have given some other number. Okay. You're able to understand that, people?
Why invalid, ma'am?
Can a binary can have a number like 8 or 7, 9 like that? It's not possible, right? It can have numbers from 0 to 7. Yeah, for these numbers we can convert. You're able to understand why?
Yes, ma'am.
Yes, ma'am.
Okay, for 74, how will we write this? 111, and for 4 it is 100.
1000.
So now this is a perfect one. Similarly, for 612 also we can be able to convert it. We have to
Ma'am,
make, yes,
one more 0.
where?
Ma'am, 100 and one more 00.
No. How? This is the value of 4, right?
Yeah. Yes, ma'am. Okay. All right.
Similarly, if it is of 612, I'll get 410. I mean 110. And for 1, it is 001. And for 2, it is 010. So this would be the octal to binary representation. Is this clear? All right, people. Okay. So these are the basic conversions.
Ma'am, could you please tell me one more time?
Yes. Actually, if it is of octal to binary in the sense of, then we have to take a octal value, which octal value in the sense of it ranges from 0 to 7. Okay. We have to take that number and we have to take, let's say if the value is 12, I have to take this 1. What is the binary representation of 1? 0, 0, 1. Okay. And what is the binary representation of 2? 0, 1, 0. So this would be the representation. Yes, Shivam?
Hello, ma'am.
Ah.
Ma'am, I face some type of issue when I'm logging to my dashboard and try to logging on my course. That shows something error. Today I have to submit my assignment, but due to this problem, I can't.
Could you please write a
I have
mail?
also emailed support team.
Okay.
Ma'am, I have written the mail, but they don't respond. They, what I don't know, but does
Could you please send your mail in the chat box? I'll just make a note of that and I'll just check with that.
okay, ma'am. Thank you, ma'am. I just sent you.
Yeah, please.
Thank you, ma'am.
Huh. Send your mail ASAP. Yes, have you sent?
Yes, ma'am. Just I am sending it. Yes, ma'am. Yes.
Okay. Okay, Shivam, I'm getting your mail ID and I'll ask the team to check as well. And if not, we'll ask the assignment. Okay.
Yes, ma'am. It's be important for me because if it doesn't know, then I can't submit my assignment, and it will have something problem.
Okay.
Yes, ma'am. Thank you, ma'am.
Huh. Okay. So I'll give one more question for octal to binary for better understanding. Okay. For octal to binary. Yes, I have sent 3 more numbers. Please give it a try, people. I'll give you 3 more minutes for this. Okay.
Hello.
Yes.
Hello, ma'am. Good
Yes.
evening. Sorry to interrupt you, but I would like to discuss a problem with you which I am facing right now.
Okay. What is the issue?
Ma'am, actually, I am a standalone student right now, but I am attending an institute which is PWIOI. It is situated in Bangalore.
Mm.
So when I was filling the form at for the BS in electronic system, the institute was not there on the list. So I have mentioned that I'm a standalone student, but actually I have my college. The lecture timing are 8 a.m. to 4 p.m. So at that particular time, I'm not able to attend any live lectures of the course.
Okay.
So I have means I have raised a ticket for this issue. So they support team at IIT Madras have asked me to connect with a course counselor.
Okay.
So
Uh,
can you provide me a suggestion or solution for this?
yeah, I'm just actually only core support team has to check with this. Okay. Could you please drop your mail ID or something in the chat box so that it'll be easy for me to check,
Yeah,
and
sure,
you
ma'am.
can ask the concerned people to connect with you as well.
Yeah, ma'am. It's actually because in a mail it has been written that for it is mandatory for standalone student to attend live lectures.
Mm.
But due to timing issue, I am not able to attend any live lecture which is scheduled between 8 a.m. to 4 p.m. This lecture is been scheduled at 6, so that's why I am able to attend it.
Okay. Yeah, that's what I'm telling you, Ma. Could you please share your mail ID here so that I can ask the concerned people to connect with you?
Sure, ma'am. Thank you. Just a second, ma'am.
Yeah.
दादी
Yes, Raj. Do you have any doubt?
కాదు ఎంతసేపు వాడుకో ఏడుకెళ్తున్నారటండి డ్యూటీ ఇంకా అన్నాను
Raj?
Ma'am, I have mentioned my email in chat box.
Yeah, yeah, I have noted that. I'll ask the concerned person to connect with you. Okay, regarding these issues.
Okay. Thank you so much, ma'am.
Yeah, okay.
Ma'am, the
Mm.
same. Ma'am, I'm also facing this similar problem
Can I
regarding the
also
timing of IT
drop my
Madras
email?
class.
Okay. Could you please provide your mail IDs, people? I'll just ask the people to connect with you.
Okay, ma'am.
Yeah. Okay. Preetham, are you also facing the same issue?
Yes, ma'am. After joining this course, I had joined a college. So it's like I had selected standalone, but now I'm a dual degree.
Okay.
Ma'am, what's about if we are in dual degree, do we have to attend the evening lectures, or we can attend it later?
I'll just ask the concerned person to connect with you people so that you can ask your doubts to them.
Okay, ma'am. Thank you, ma'am. Ma'am, it's a recent update, so many of our student are like confused about it.
I didn't
Like,
get you.
ma'am, like attending lecture is compulsory recently, like from this semester only. So
Hmm.
many student are confused about it.
Oh, okay. Okay. Others, have you all tried converting?
Yes, ma'am.
Okay, great. So far we have discussed about converting and all, right? So next we'll discuss about the negative integer values. Actually, the data can be represented in four ways. Okay, one is of signed way and the another is the unsigned value. Do you know what is signed and unsigned?
Signed means if we put a zero, then it will be positive, and if we put one in front of the written binary digit, it will be treated as negative.
Yes, it's right.
Signed means negative and unsigned means positive.
Exactly. Good people. So you all have an idea, right? Like what is signed and unsigned. So let's say if I'm giving us 8. So how to represent 8 actually?
One, 1, 0, 0.
0, 1, 0.
Simply 8 will equal to 1, 0, 0, 0.
Huh. Yes. Generally, if I'm representing, no, I'll just use it as 1, 0, 0, 1,
0,
0. How about minus 8? How to represent this?
1, 1
We
and
put
triple
1
zero.
after 1.
Okay. So generally, we'll just mention the starting as 0. Here, I have to make it as 1. And also, we have to find the 2's complement of this number. Do you know what is 1's complement and what is 2's complement?
Yes, ma'am.
Okay. What is 1's complement?
Uh, one's complement, we invert all the digit 0 to 1 and 1 to 0, vice versa.
Exactly. We'll toggle the values. Let's say if the given number is 15, not 15, let me take some 14 as a value. So how to convert a 14 to a binary?
Uh, 1110.
Yes. 14 is written as 8 is filled, 4 is not filled. No, 4 will also be filled, right?
Yes, ma'am. 1110.
Yeah, it's 1110. Okay, so now if I have to find the ones complement in the sense of all the ones has to be converted to a 0 and 0 to 1, 1 to 0. This is what is ones complement of 14. What is two's complement?
When we add 1 and
At the
addition, yes, ma'am.
yes,
Addition of
if
1
I add 1 to it, then it is considered as the two's complement. 1 added in the sense of we'll get 0 as the remainder
and carry
and
1.
1 as a carry. Yeah, and then 1, 0, and 0. Okay, so this is also the same as signed. This is, we can say it as the negative value of 14. So minus 14 can be represented as this way also. Okay, which is nothing but 2's complement of the given number. Is that clear?
Yes, ma'am.
So either
Yes,
I
ma'am.
can just write it in this way, nothing but I can just give it as first bit has to be changed to sign bit, all the other bits has to be the same, or else you can represent it by taking the 2's complement also.
Ma'am, repeat the two complement.
Okay, I'll tell you. So first is, let me take value as 13, or let's say take some other value as 22. So how will you represent 22? Yes. People, how will you represent 22 to the base 10 to the base 2?
1 0 1.
10110.
I'll get here 1 0 1 1 0. This is the
One
base,
zero.
right?
Yes,
1
ma'am.
0 1 1 0, right? If it is of 1's complement, I have to invert it, which is nothing but I have to give 1 0 1 0 0 1, like this. Nothing but we are toggling the values. Here it is 0 toggle to 1, 1 is toggle to 0, 0 toggle to 1, 1 to 0, 1 to 0, 0 to 1, like this. Is it clear?
Yes, ma'am.
Okay. Now I have to go to the 2's complement. So for finding the 2's complement, what has to be done? I have to add 1 to it. Okay, which means plus 1. If I add 1, what will happen? 1 plus 1, answer is 0, carry is 1. 1 plus 0 is 1, 0, 1, 0 and 1. So this is the 2's complement of the given number. Is this clear?
Yes, ma'am.
So you can represent the negative number in two ways. One is by taking the 2's complement of a given number, or else you can just change the signed bit. Only that is also fine. Is this clear
Yes, ma'am.
to everyone?
Yes, ma'am.
Then last step.
This step, adding step.
Yes, ma'am. Last step.
Okay. So generally what we have to do here is, first we have to add 1 to it. So do you all know binary multiplication? Sorry, binary addition?
Yes,
No,
ma'am.
ma'am.
Okay. So binary addition, I'll tell you only for 2 elements as of now. Okay. So let's say we are taking 0 0 and then 0 1. I hope my writings are visible, right?
Yes, ma'am.
Okay. So now we'll have 2. One is of carry. Hold on, people. Okay. So the next is of the normal value. That is nothing but result. Okay. What is 0 0? If I add 0, carry is also 0. Result is also the 0. 0 plus 1, is there any carry? No. But the result will be 1. In case of 1 and 0, there is no carry, but the result is 1. Okay. How about 1 plus 1? If it is of 1 plus 1, carry is 1, result is 0. Okay. And in case of 3 ones, that is A, B, C, then we'll get result as 1, carry is also 1. Is this clear?
Yes, ma'am.
Okay. If it is of only A and B, then we have 0 0 0 1 0 1 1 0. So this is one is carry and the other is result. If I'm adding only 2 elements, then it's like 1 and 0. Result is 0, carry is 1. The same way which I'm trying in the previous elements also. Okay, let's say if I'm taking as 26. So what is the binary value of 26?
Yes, ma'am.
This is the value, right?
Yes, ma'am.
because here it is 1, 2, 4, 8, and 16. 16 plus 8 plus 2, I'll get it as 26. So what is the ones complement of this?
00101.
Yes. What is the twos complement?
00110.
We need to add 1. So 0, carry
0.
forward this 1. So it's 1, 1, 0, 0. It's 0, 0, 1, 1, 0. This is the twos complement, or you can say it as the minus 26 value also. Is this clear, people?
Yes, ma'am.
To everyone?
Yes, ma'am.
Yes, ma'am.
Great. So this is how I can be able to represent the negative values. Okay. Either I can take a inversion or we can take this twos complement. Next is of floating point representation. Do you know what is floating point? Floating values.
Yes, ma'am. Pointed
Decimal maybe in
like 2.1.
2.4 something.
Yes, right. Good understanding, people. Let's say if I'm giving us 5.126, or let's say, let me give the easy value as 5.50. Now this is of decimal 10. I want to convert it to the base of 2. How will you convert this? Any idea?
Firstly, we convert 5 into binary.
Yes, perfect. So what is the binary value of 5?
Uh,
01.
101.
101 is the
101.
binary value of 5. How about 0.50? How to convert this 0.50? Any idea? You can just tell people.
No, ma'am.
Ma'am, 5 divided upon 2 ka power 1 plus 0 divided upon 2 ka power 0.
Huh. You can do it in that way. Otherwise, what you can do is, it is 0.50 into 2. What is 0.50 into 2?
That's 1.
It's 1. So 1.0. After this, I don't want to do any process. So I have got 1, right? So that is what is taken. 101.1.
Ma'am,
Like,
why multiply by 2?
it's 2 to the base of minus 1, minus 2, minus 3, like that, right? It's a binary value which I'm trying to convert.
Ma'am, repeat it again.
Okay, let me take some other example here. Let's take 0.75 here. Okay, some number 0.75, or let's say it's 12.75, something like this. Now I have to take this 0.75 for conversion. So generally, if it is of 25 or 12, whatever is the given number, you can just write it in the same way. But for this one, I mean, after the decimal point, what you need to do is you have to multiply it by 2, so that you can be able to get the after point, I mean, what after floating point, how to convert that. So it's like 0.
Means if some ma'am means if something is after point something like 754, then we can take 3 to multiply by these number.
No. If it is 0751 also, let me take one more value here, 1. Still, I have to take a 751 into 2 only. It's like we are converting it to a binary, right? For that purpose, we are multiplying it by 2, and whatever the number we are getting, I'll tell you now. 1 minute. Let's take 0.75. Okay, how to convert this? So what I'll do is 0.75 into 2. What is the value we'll get, people? 1.5. So I have to take the 1 separately. Okay. Now, what is the remaining here? 0.5. 0.5 into 2, what is the value we'll get?
1.
1.0. So if once I got 0, I don't need to proceed with the further steps. So I'll take as 1 and 1. So answer will be 1, 1 to the base of 2. So this is of one way of doing. I mean, like, this is the way of doing it. Let me give you some other number like 625. 0.625. How to convert it?
First, we have to multiply 0.625 into 2.
Yes, 0.625 into 2, what we'll get? 10, 5, 1.350, right?
Yes, ma'am.
So take 1 separately. Now what is the remaining? 0, 350 into 2. What is the value we'll get here? 0.70, right? So
Ma'am,
here what is the first value?
1.250.
50.
How?
1.250.
0.625 into 2 will be 1.250.
Okay, 250. Fine, 250. Okay, anyway, we'll get it as 500 here, right? Okay, so here out of 1.250, I'm taking this 1 out. So I have to take it as 0.250. Now 0.250 into 2, I'll get it as 0.5. Now take 0.5 into 2. What is the value I'm getting here? It's 1. 1. So I have to represent this as 0.101 to the base of 2. I have to write in this order. First, second, third, like this. Not any reversal order or something. Is this clear?
Yes, ma'am, clear.
Can I
Yes,
give you
ma'am.
one more number to understand what it is?
Obvious.
Sure, sure.
Okay. No, if you're adding zeros in the first, that's not any issue.
Thank you, ma'am.
Okay. All right. I'll just send it in the chat box now, people. And I could see Manoj, you have sent your mail ID. Why? And I could see the both three also added your mail IDs. Is it regarding that not standalone, but you previously have filled as standalone, is it?
No, ma'am. Actually, I couldn't able to attend a few live sessions, so I filled it just in case.
Okay. The both three? Hi. Is the both three? Yes, for people, I have sent the floating point in the chat box. You can just check and try converting it, people. Can we do it as parallel, or you want some time to try? Yes, people.
Yes, ma'am. Let me some time to do.
Okay, I'll just give you 3 more minutes, people. Just give it a try. If you are not able to do also, just let us know. We'll do it. Okay.
Okay, ma'am.
Yeah. Yes, everyone. Have you all tried?
Ma'am, it's getting very long value.
You can just stop at the second or third step. You can just mention as only 0.2 decimals instead of keep on moving.
Okay, ma'am.
Yeah. Others? Anybody face any issues?
To the 653, it's continuously adding.
I didn't get you. Could you please speak a bit louder?
Ma'am,
think I'm the same issue.
101001.
Huh, that is fine. You can just stop at second, third or fourth step. No need to go further because it will take time consumption, right? Generally, we'll just give 0.3 or 0.4, right? That is fine. Okay. Shall we try the answers for that? Okay, so the first thing is 0.65, right? 0.653. So for 0.653, what I need to do first multiply it with 2. Okay, so what is the value I'll get here?
1.30.
1.30.
30.
30.
6.
Yes. So what I need to do then? First I have to take this 1 separately. Now what is the remaining values? 0.306 into 2. What is the value into 2?
0.612.
Yes, I'll get it as
612.
0.612. So out of which we have to take 0. And next is of 0.612 into 2. What is the value?
1.224.
1.224. I can take 1. So 101 is the value which I can take. I no need to go further. Because here I'm just asking you to find, right? So if they have given us, you have to find 4 or 5 decimals, then you have to keep going till that point. Here you can just find 3 or 4. That's fine. Because it's like for your understanding purpose. Is that clear?
Yes, ma'am.
Okay. Similarly, let's say if I'm taking the next value was 0.725. So how to do that? 0.725 into 2. What is the value I'll get? 1.5, right? No, 1.42450. Right?
Yes, ma'am.
Okay. Now I have to take 1 separately. So I have to use a 0.450 into 2. What is the value I'll get? 0.900. So take 0. Then 0.900 into 2, 1.800. Take 1 separately. Now 0.800 into 2, you'll get it as 1.6, right?
0.6.
Yeah, take it as 1. That's it, more than enough. Similar with 567 also. Is these things clear?
Yes, ma'am.
Yes, ma'am.
So now, if I'm representing this one, this after a decimal point, we have some values, right? This will say it as a mantissa. Okay, so how to generally, if I want to find the value of binary, let's say I'm taking the number as 5.62. So how yeah, we can take this 653, right? Okay, so how to represent this? For 5 is 101.653 can be represented as 101. Okay, now what I need to do is I have to do a normalization here. So normalization in the sense of first we can be able to write as there are two ways of normalization here. One is of implicit and the other is of explicit normalization. So implicit in the sense of this is the radix point, right? Moving this to the let's say LHS. What is the MSB here? What is LSB and what is MSB?
MSB is 1.
Okay, what is the most significant bit then?
Ma'am, MSB most significant digit is 1.
This is MSB, right? And
Yes,
this
ma'am.
last one is the LSB.
LSB.
Yes. So this last one is the LSB. Now, what I need to do is I have to take this dots, which means that what they'll say, the decimal floating point, right? So where I'm keeping that floating point, based on that, we'll say whether it is a implicit normalization or explicit normalization. If I keep this dot before the MSB, which means 0.101101. So this is the explicit normalization. I'm keeping this radix point before the MSB, most significant bit. There is left side of most significant bit. If it is of explicit, so of course I have to take to the power of 2. So 2 to the power of 3. Okay. Similarly, if I have to do the implicit normalization, implicit in the sense of the floating, that point has to be taken to the RHS of the MSB, which means it has to be represented as 1 point. Okay, now my writings is visible, right? So 1.0 and then I'm writing the all the other elements. That is 0, 1, 1, 0, 1. So this we'll say it as the implicit, and this is of explicit. And this is of implicit. Is it clear?
Yes, ma'am.
So moving the radix point to the LHS of the most significant bit is explicit. RHS in the sense of, we'll say it as the implicit normalization. Okay. So first, after doing this, we have to represent it, right? So for which we'll use this biasing one. So first is the sign, next is the exponent, and next is the mantissa. What is mantissa? Yes, what is mantissa, people?
Ma'am, I don't know what is meant.
Don't know, ma'am.
Just now I mentioned, right? After decimal point, whatever the values are there, that is said to be the mantissa. Which means
Okay,
here
ma'am,
this is
got
said to be the mantissa. In this case, this is said to be the mantissa. Is that clear?
Ma'am, actually, please repeat this last line because our network connection has been aborted.
Okay. So actually, we have to do the normalization here. Okay. So whatever the number is given, we have to do a normalization. Normalization is of two types. One is of explicit and the other is of implicit normalization. Okay. So explicit in the sense of taking the like that radix point to the LHS of the MSB. Then it is said to be explicit normalization. If the radix point is after the MSB in the sense of, then it is said to be implicit normalization. Is this thing clear?
Yes, ma'am.
Okay. So the next thing is biasing. In case of biasing, we have this one. So first is said to be the sign bit. Next is said to be the exponent. And the last one is the mantissa. Okay, mantissa in the sense of, let's say if I'm giving us 101.1 to 1 1 0 like this. Okay, so this 110 is said to be the mantissa. Now of course we'll do some normalization, so out of which we'll get the exponent. Exponent you all know, right? If I give 10 to the power of 2, this 2 is said to be the exponent. Similarly, in case of here, we'll have it as 2 to the base power of 2 or 2 to the power of 3 or 4, whatever it is. This is said to be the exponent. Is that clear?
Yes, ma'am.
Okay. So here we have
Yes,
a
ma'am.
signed numbers,
Clear.
right? Do you all know what is signed number?
Yes, ma'am.
Okay. What is signed number?
Negative numbers.
Yes. So let's say I have to represent from 0 to 7. How will you represent a positive 0 to 7?
Positive 7.
Yeah.
One, one, one.
Yes.
1, 1.
Yeah, right. How to represent 1, 2, 3 and all? Can you please tell me in the order?
Zero and then
Yes, ma'am.
one
0,
and then
0,
All
1,
0,
0.
1.
zeros. Okay. How about 2?
0,
0,
0,
0,
1, 0.
1, 0.
Okay. 3?
0, 0, 1, 1.
Okay. How about 4?
0, 1, 0, 0.
Okay. 5?
0, 1, 0, 1.
Okay. 6?
0, 1, 1, 0.
0, 1, 1, 0.
Okay. 7, 0, 111. How will you
0, 1,
represent?
1.
Yes. So, let's say, how will you represent negative 1?
Instead of 0, I add 1 in front. A digit.
1, 3 zeros, and 1.
1, 3 zeros. I said you can take a complement, right?
Ma'am, 0, 0, 1, 0.
Yes, ma'am.
No. Do you all remember how to take 2's complement? First, you have to take 1's complement.
Yes,
On
ma'am.
1's complement, 1, 1, 1, 0. How about 2's complement?
Add
1,
1.
1, 1, 1,
Adding
right?
1.
So this will be the negative 1. Got it?
Yes, ma'am.
Yes, ma'am.
Okay. Now tell me how to take the negative 1 here. Negative 1 representation. Yes, people, start telling it.
1, 1, 1.
Yes, 1, 1, 1, 1. And how about negative 2?
111, 0.
Yes, perfect. 1110. How about minus 3? 1101, right?
1, 0. Yeah.
Can you all able to understand these people?
Yes,
This
ma'am.
minus concept is like we have to do one's complement, ma'am.
Yes, first you have to do the ones complement. After ones complement, add 1 to it. Let's say I'm taking 4. What is the value of 4?
0, 0, 1, 0.
0, 1, 0, 0, right? If I take a ones complement of this, what is the value?
1,
1,
0,
0,
1,
1,
1.
1.
1, 0, 1, 1.
1, 0, 1, 1. How? Once, yeah. Correct. I have to change it to 1, 1. Okay. Now after this, I have to do the 2's complement, which means add 1 at the end. So what I'll get? 0, 0, 1, 1, right?
Yes, ma'am.
So the negative value of 4 is minus 4 is?
1, 1, 0, 0.
1, 1, 0, 0.
Okay. How about 5?
1, 0, 1, 1.
Perfect. How about 6?
1, 0, 1, 0.
Perfect. And how about 7?
1, 0. Sorry.
1, 0, 0, 0.
1,
1,
0,
0, 0, 0.
0, 1, right?
Yes, ma'am.
For 1's complement, we'll get 1, 0, 0, 0. After adding 1, we'll get 1, 0, 0, 1. How about minus 8?
1,
1 zeros.
0. Yes.
Okay. Can you able to understand these people?
Yes, ma'am.
Everyone?
Yes, ma'am.
Perfect.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, what I need to do is, yeah, perfect people. If I have to fill in this sign, exponent, and matrice, what I need to do is, we have to take these values. So, how? Let's say, what is the range of this value? I'm getting the elements from minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus
0.
1, 0, 1, 2, 3, 4, 5, 6, till 7 we are getting it, right? Isn't it?
Yes, ma'am.
Okay. Now what I need to do is, out of which is the maximum element, irrespective of sign, which is the maximum element?
7.
Irrespective of sign, which is the maximum value?
No.
8.
8. 8.
Minus 8.
Exactly. So you have to add 8 to it. 8 to all the elements. If I add 8 to all the elements, what will we get?
0, 1, 2, 3, and so on.
Yes, we'll get the values from 0, 1 to 15, right?
Yes, ma'am.
Yes,
This
ma'am.
is what we are going to take for an exponent. Let's say if the value is 2 to the power of minus 3. So for minus 3, whatever the value is assigned, we have to take that and we have to fill in the exponent within this 4 columns. Got it?
Yes, ma'am.
Yes, ma'am.
That is minus 3 plus
So
8. What
like
is the value?
-3 is binary plus 8 is binary, ma'am.
No, just 8 plus 8.
Like we have to like so for -3 we are having 1101. To that we have to add 1111.
No, you're not
It is like
adding
that.
that. No, nothing like that. Let's say I'm taking minus 8 plus 8. What is the value? 0. Minus 8 plus, sorry, plus 8 minus 7. 1. So similarly, minus 3 plus 8. What is the value?
Plus 5.
Yes, I'll get it as plus 5. How will you fill 5?
101.
Yes. Similarly, if it is a 4-bit, I have to fill it as 0101 like this. This is how you have to fill the exponent.
Okay, ma'am.
If the value is 2 to the power of plus 2, then what is the value assigned? 2 plus 8 is, I'll get it as 10. So what is the value of 10? Binary value of 10 is 1010, right?
Yes, ma'am.
Yes, ma'am.
1010.
So here I should fill it with 1010 like that. Is that clear, people?
Yes, ma'am.
See everyone?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes. Someone have raised their hand. Do you have any doubt?
No, ma'am.
Okay. So after this, whatever is the mantissa, fill it. Let's say here I have got mantissa as 101. So fill it as 101 like this. If there are remaining elements, you can just, at the end, you can add it as zeros. Okay. So sign is based on whether it's a positive number or negative number. I have taken 5.5652, right? Which is a positive number. So sign has to be 0. Got it? This is how the floating point has to be represented.
Yes, ma'am.
Is it clear, people?
If it's a negative
Yes, ma'am.
number,
You have to fill this one as 1. If it is of negative, fill it as 1. If it is of positive, fill it with 0.
okay.
So that is what is explained, right? Yeah. Okay. So next is of the character representation. So do you know how to represent a ASCII code? What is ASCII at first?
Ma'am, ASCII code is the code of language for the understanding for the computers.
Yes. Let's say its full form is American Standard Code for Information Interchange. So let's say if I'm giving us A, so it has a binary value for this. Okay. Uppercase A is 65. B is 66. C is of 67. Similarly, till Z we have the values.
Ma'am, is this our decimal value?
No, it's an integer one. So to the base of 10. This can be converted to the base of 2.
Okay, ma'am.
Okay, based on that, the computer will think, okay, I have to now process for a character like that. So instead of character A, it will take this binary value. For the identification purpose, we are using this. Got it?
Okay, ma'am.
So 65 to 90 is uppercase A. Similarly, we have a lowercase a. So for lowercase a, it starts with 97 and Z with 122. You can just remember this as plus 32. If you remember this uppercase, plus 32 is uppercase. If you remember lowercase, minus 32 is uppercase. You can just remember any of that. Is that clear?
Yes, ma'am.
Okay. And similarly, for 0 also we have it. For 0 as a ASCII code, we have it as 48. Okay. And how about 9? It's 57. Got it?
Yes, ma'am.
Okay. So this is how you have to take the ASCII values. So initially it was only 127. Later we have this extended code
which is for this E with this slash, A with this slash. For all the values, now we have got the ASCII code. That is what comes under the extended ASCII code. Okay.
Ma'am, we have to remember all the ASCII code.
No. You can just remember the few things like for A, uppercase A 65 ends with 90. So meanwhile, you can be able to remember this lowercase one. And you can just take for zeros 90, 48. Of course, the 9 is 57. You can remember at least the starting. Based on that, you can calculate it.
Okay, ma'am.
Is that clear, people?
Yes, ma'am.
Okay. Do you have any doubts so far, ma? Yes. No? Okay. So the next will be of instruction encoding. So instruction encoding in the sense of instruction can have a okay, people. Instruction will have a opcode and then instruction formats. So instruction format in the sense of it's like RISC and CISC. RISC in the sense of reduced instruction set computing, which means it will take a single clock cycle. Okay. If you take and RISC is for simple instructions also, and CISC for complex instructions. Okay. And this opcode contains the like it is to perform some operations like addition, subtraction, for all those things. No, I'm not sharing my screen now because for writing I have used the screen. Okay. And the next is of program compilation. Do you all know how the program is compiled or what are the stages of compiling? Yeah, just give me 2 minutes, people. I'll end the session in 2 minutes.
You mean a high-level language to assembly language to do machinery?
Yeah, we have to do the pre-processing at first, which includes this header files, macro expansion, and then conditional compilation, which means we'll give a if def. If the definition is, if the value is not defined from the user end, they can take this if def. Okay. And next is of compilation process. So compilation in the process in the sense of it has to convert the source code into a assembly level language, which is nothing but taking the lower level language. Okay. And then assembly in the sense of it will convert from assembly level code to the machine code. Machine code in the sense of zeros and ones. So once this process is done, it moves to the linking process, where it will take it into a single executable file, like compiling all the object codes and then the libraries into a single executable file. Okay. And then next is of OS. OS is nothing but the operating system. You all know OS, right?
Yes, ma'am.
Okay. So OS in the sense of it is the base one. Okay. So using which only the software and hardware will get communicate and it will do the process. If the hardware has to communicate, this OS acts as an intermediate part for it. Okay. The functions includes processing, which means what process has to be done first, like allocating and scheduling processes and all. And next is of memory management. So whether it has to be stored for a long term or it is just for the temporary purpose. And then the file processing. So file management in the sense of whether who are all able to process those files, access can be given. And next is of device management, which means whether it's the input or whether you have to give the output, what data has to be transferred, all these things. And next is of user interface, which is like you all know graphical user interface, GUI, right?
Yes, ma'am.
The same thing. And next is of security, which means who can be able to do and who cannot be able to do. Like only few people I can give access. I'm not going to give access for all the people. Okay. And next is of booting. Do you all know what is booting?
Yes, ma'am.
Nothing but starting. You can see in mobile also we have reboot. You can restart. It's like a start. Okay, which means the OS loads all the memory and makes the computer to start or turning on process. And next is of this BIOS, which is nothing but basic input and output system. So yeah, that's it of the week one summary. So do you have any doubts so far? And regarding notes, I'll check people. If it is shareable, I'll share it with you.
Ma'am, the last
Huh.
session notes can I get?
For last session, I don't think so. I have used the lectures or PPTs.
Then you started from here, from this lecture.
Yeah. Only for this lecture, I'm starting using this notes. Or else you can just check this people. You can have the notes like PDF one. You can use it.
Okay, ma'am.
Yeah.
Ma'am, I have said that I can't get my page of course due to some problem, but ma'am, this
Huh.
doesn't resolve at that time. Due to this, I can't get my page and can't upload my assignment.
Yeah. I think the first week assignment due deadline is tomorrow. I'll try to.
Yes,
I have.
ma'am. That's why I am very
Okay.
panicked today.
Okay. I think it will end by tomorrow evening, right? Yeah. Tomorrow night. Till that you have time. I'll
Tomorrow
check with.
night 12,
Yeah.
12 a.m.
Yeah. Which means
But I have
when
to.
I'll check with my team. I have already forwarded it, and once it is done, you'll be able to access it.
Yes, ma'am. Please, ma'am.
Yeah, I understand.
Very panic to me. Very panic.
I understand. Okay.
Thank you, ma'am.
People, if you have no doubts, you can leave the session now. Thank you.
Thank you,
Thank you,
ma'am.
ma'am.
Yeah.
Thank you, ma'am.
Thank you, ma'am.
Thank
Yeah.
you, ma'am.
People.
Thank you, ma'am.
Thank you.
Yeah, people.
Thank you, ma'am.
Good night, ma'am.
Thank you, ma'am.
Yes. I think some people have raised hand. Yes, Danpat.
Yes, ma'am. Actually, I have a doubt in like truth complement. How
Okay.
to how to add one?
Okay, I'll tell you. Is my screen is visible now?
Yes, ma'am.
Okay. Let's take a value as 32. What is the binary representation of 32?
Like
1, 4, 8, 16, 32, 64, right?
yeah,
So only 32 gets 1, all the other
zero
values
zero
are 0. Now, how
yeah
to write the ones complement of this?
0 1 1 1 1 1.
1, 0, 1, 1, 1, 1, 1. Now, to get the
Yes.
2's complement, add 1 to this binary value. Okay. So, if it is of A and B, binary addition in the sense of 0, 0, 0, 1, 1, 1, 1. So here we have a carry as well as the result. So if it is of 0, both are 0. 0 and 1, carry is 0, result is 1. 1 and 0 also, carry 0, result 1. If it is 1 and 1, carry is 1, result is 0. Is anything clear?
Ma'am, I have to remember these.
It's very simple, man. If it is of 1 and 1, it's carry 1, result 0. Others are similar adding. Like if you add 0 with 1, you'll get it as 1. The same way. This is
Okay,
a
ma'am.
binary addition. Okay. So if I add 1 and 1, what has to be the result? 0,
0
carry as
1
1. 1 and 1,
0
result 0, carry as 1. 1 and 1,
0
0, carry as 1.
1
1 and 1, 0,
0
carry as
carries 1
1, 1, 0, carry
0
as 1.
carry
1, 0,
0
result is 1.
1 1 1. Yeah.
And the next is 1 only. So 1. So this is the 2's complement of 30. So 32. That's it.
Okay, ma'am. Now I understand.
Okay, great.
Thank you, ma'am.
Yeah, okay, ma'am. People, do you have any other doubts?
Ma'am, one more doubt I had.
Yes, Danpat.
Like, it's not regarding course, but it's regarding attendance.
Okay.
Actually, I had attended the live session of ESTC,
Hmm.
but I didn't show my name on the live session tracking PDF.
Okay.
So what can I do for that?
You need to check with the like support team regarding this.
Actually, I have written to the support team, but they respond to me like you have to contact the instructor.
Okay, then who's that class instructor? You need to contact them.
At that time, there was a sir.
Huh?
There was a sir.
Could you please, when you are attending the next session, could you please ask the same to them?
Okay, ma'am. I will.
Yeah, please.
Thank you, ma'am.
Yeah. Okay, people, do you have any other doubts? If you have no doubts, you can leave, people. Thank you.